Alright, I've drawn a unit circle for you here with a point P on it and a line segment running from the origin towards that point P. And we know that the height of this point right here, which is also called the y-coordinate, is equal to the sine of the angle between the positive x-axis and this line segment right here. So if we call that angle alpha, then the y-coordinate is equal to the sine of alpha. And we also know that the x-coordinate is equal to the cosine of that same angle. And that really is a stellar result, because that means we can convert coordinates into trig functions. Which, in other words, that means that when we make an observation about points, let's say we do an operation on this point, like we flip it through the x-axis or y-axis or both, and we do some sort of observation about what happens to the coordinates of the points, then we can convert that back into trig formulas to essentially generate trig identities. And to give you an example of that, I just wanted to tell you, well, let's just take the example of flipping this point P through the y-axis. Right, so just mirroring it through the y-axis. That's another way to say that. And then we end up with a mirror image of P right here. I'm going to call that P prime. And we know a lot about the coordinates of this new point. We know, for example, if we mirror it through the y-axis, then its height remained unchanged. So the y-coordinate of this new point is equal to the y-coordinate of the original point. And we also know that the x-coordinate really just flipped from one direction to the other. So it became negative. It might be, if the point P was on this side of the circle, the result might be positive, but we take the negative of the original value, the original x-coordinate. And with this observation, as we just said, we can convert this to trig formulas using this rule right here, that the x-coordinate of a point is the cosine of the angle corresponding to that, and the y-coordinate has the same thing going for it with regards to the sine. So that means we have to figure out what angle corresponds to this line segment, right? So what is this angle right here? Well, notice, first of all, we know that this angle, the angle between these two line segments, is also alpha, right? And we also know that the angle of the half the circle is equal to pi. So that means that we pretty much, you could imagine a point moving along here by an angle of pi and then going back by an angle of alpha. That means we took pi and we subtracted alpha from it. And that means we now have our angle, so the y-coordinate is converted to the sine of the corresponding angle, pi minus alpha. And apparently that's equal to the sine of alpha. And we can do the same thing for the cosine, but bear in mind, here we have to add a minus sign, because that's what happens when you mirror something through the y-axis. It becomes negative. And the corresponding angle here is alpha. Okay, so that means now we actually have a trig identity that we can use, for example, when simplifying a certain formula, right? And that means that when we want to prove a trig identity or even generate a new one, we can usually do so by looking at the angles that are involved in the trig identity and making observations about the coordinates of the points that correspond with that, right? So, for example, the point P here corresponds with this angle of alpha in this particular way that we've done it here. And that way you can just prove all sorts of trig identities, and you can even come up with your own ones. So that's a pretty neat thing to do. It's a pretty entertaining way to, you know, get some hands-on experience with trigonometry, which can be confusing if you just have to rote memorize all these sorts of things. So that's just what I want to show you in this video. I hope you found it useful, and I'll see you in the next video.